Hello everyone, welcome to Pepcoding. In this video, we will look at the question, where will the ball fall? Okay, so in this question, we are given a grid like this, right? We are given a grid, and this grid is open from the top and from the bottom, right? It is open from the top and the bottom, right? And it is covered from the left and the right hand side. Okay, so it is covered from the left and the right, but it is open from the top and the bottom. Now, we're given some balls, right? We're given some balls, and it is saying that in this board, in this grid, there are some boards. Okay, so let's take this cell for example. Let's take this cell, right? Here we have a board, something like this, right? We have a board which looks like this. Now, if you drop something on this board, if you drop something on this board, it is going to go in the right direction. Okay, it is going to go in the right direction. If you have a board like this, for example, if you have a board like this, and if you drop something on that board, it is going to go on the left hand side. Okay, so what do we have? We have a grid like this, and in that grid there are certain cells, and in that cell there are some boards, right? So if we say that this is a cell, right, and my board is like this, right, then if the ball falls here, it is going to go on the right. Okay, let's say I have a board like this. I have a board like this, right? Now, if the ball falls on this board, it is going to go on the left hand side. Okay, so this board or this grid is represented by ones and minus ones. Okay, so if we have a board which looks like this, right? If we have a board which looks like this, it is represented by 1, and if we have a board which looks like this, right, like this, then it is represented by -1. Okay, so we have a board where we have values like 1 1 1 -1 -1, right? 1 1 1 -1 -1. So if you have a board like this, it is -1. If you had a board like this, it is 1. So now we know what the boards are, right? We're given some balls, and we are saying that we have to drop these balls on these boards, and we have to check that if these balls are going to fall from the board, and if they are going to fall, tell me the column from which the ball is going to fall. Okay, so let's say I'm talking about the zeroth ball, right? I'm talking about this zeroth ball. This zeroth ball. I'm talking about this ball, right? So it is going to fall like this, right? It is going to go. It is going to go like this, right? And it encounters a 1, right? So it goes on the right hand side. It falls again, right? Then it encounters a 1 again. It goes on the right, right? Encounters a 1. It falls again, right? It encounters a -1, so it goes on the left hand side. It falls again, right? It encounters a 1, goes on the right hand side, falls again, right? Goes on the left hand side, then falls again, and comes out from the first column, right? This ball, zeroth ball came from the left hand side. This ball came from the this came out from the first column, right? So we will have a column array, right? We will have a column array which will be representing the balls, right? Which ball is going to fall out from which column? So if ball 0 falls out from first column, then I'm going to fill 1 here. Okay, similarly, let's say we have ball 2, second ball. Okay, it falls down, it goes on the right, right? It falls down, it goes on the right, and it encounters a -1, right? Now we have something like this. We have a case like this. Now if a ball falls here, then it is going to go on the right hand side. If it sees that there is a board like this, it is going to go on the left, then it is going to go on the right. right? So it is going to stuck, it is going to be stuck in between these boards, right? It is not going to ever come out. So this ball one will be stuck in this loop and it will never come out. So we will store -1 here, right? That this ball never came out actually. Similarly for ball 2, it is going to go here, right? It's going to fall here, then go to right, then left, right, and stuck. Okay, so I'm going to store -1 here as well. For ball 3, it's going to go, it is going to fall on left, right, stuck, -1. Ball 4, it's going to drop, go on the left, drop, go on the left, then on the right, on the left, stuck, -1. Okay, so I'm going to return this as my answer array. That the first or the 0th ball came out from the first column and the rest of them were stuck in the maze. Okay, so how are we going to solve this question? Okay, we will solve this question using brute force method. We're going to solve this question using brute force approach and just see how we are actually solving the question. Let's take uh, two variables called current position and next position. Okay, they will decide when I'm going to fall or at which position I'm going to move. You see that every time we are traversing, right? Every time we are taking a step, my ball is actually falling only, right? The ball is falling only, but this board will decide if it will go on the right hand side or on the left hand side, right? I am falling, or I am always falling. This ball is always going to fall, but this board will decide. But the board here will decide if it is either going to go on the left hand side or on the right hand side. Right? The ball is always going to fall. So, uh, with our current knowledge, let's try to code a little. Okay. So the first thing we need is grid dot length. Okay. So we will need our grid length and m equals to grid of 0 dot length. So we have our rows and columns. Now we will make an answer array of m size, right? Of column size. Now int j will go from 0 till m. Right? We are actually finding the answer for all the columns, right? And here we will have our current position and our next position, right? And we will initialize them in a second. And after that, we'll just return our answer, right? If this for loop will do all the work and I should get my answer and I should return my answer from here only. Okay, so what we are actually trying to say? We are saying that we have a current position which will start from my j and my next position, let's assume it to be -1. Okay, what is going to be my next position for every case? For every case, you will see that when I'm encountering a 1, right? This means a 1 and this means a -1. If I'm encountering a 1, why don't I add this to my column, right? If I add this to my column, it means if I add this to my column, it means that I'm taking a step on the right, right? If I add this to my column, if I add this to my column, right, it would be -1. It means that I'm taking a step on the left, right? So I can handle the edge cases later, but where am I going to move? I'm going to decide that on the basis of my current position and my next position, right? And I can just add them to my column and I can make the direction move because I'm always falling, right? The rows are always going to increase no matter where we are actually trying to go. But this 1 and -1 will decide on which direction I will go. Okay, so I have this current position and next position. This current position will be j and this next position will be -1. Let's initialize them like this. Now we will have a for loop which will go from 0 till n, right? Because my ball is always falling, right? Now my next position will be current position plus grade of I comma current position. Okay, now this is saying that I'm increasing my column every time, right? I'm deciding the next position. I'm deciding the next position on the basis of what my current value is. If it is +1, then I'm just adding it to my current position. Then I'm going to go on the right. Okay. If it is -1, then I'm going to go on the left. So if it is 1, then right. If it is -1, then left. Okay. And if now see that since we are traveling like this, since we are traveling, right? If we have a position like this, if the ball were to go here, right, it would go on the left hand side and it would be stuck on the board, right? If it is stuck on the board, then it is not going to come out, right? Similarly, for the case like this, right, if it is going to go here, if it is going to go on the right hand side, it is going to stuck here, right? So we have two cases where the ball is going to be stuck. And we also have a case like this, right? A case like this, that if a ball goes on this direction, then it goes on the right, right? And if it goes on the left, then it goes on the right. So it is stuck in between as well. So we have a case where it is going to go on the left or on the right board, and a case where the current direction plus this is, let's say, 1, right? This is 1 and this is -1, right? If we have a case like this where 1 is followed by, right, or we have 1 and -1 right next to each other, then the ball is going to fall and it is going to be stuck in between. So I'm going to say that for that case as well, for that case, I'm going to break from that loop. Okay, I'm going to say that the ball is stuck. So I have my three cases. If my next position is less than 0, or if my next position is greater than equals to m, or if my grid of I comma current position is not equals to grid of I comma next position, right? Then I'm just going to say my current position will be -1 and I'm going to break, right? And after this, if it does not encounter, then my ball is just going to fall normally, and I'll say that my current position is next position. So after this loop runs, I will have the current position as my correct answer, right? Of which column did I come out? So my answer of J will be current position. Okay, so this is my code. I hope you understand the approach as we coded. Now let's try to run this code. This is successful. Let's submit this. Is also passing the test cases. So I hope you understand this question. Don't forget to like, share, and subscribe. Thank you for watching.